3 minutes ago isn't really where this story begins. It actually begins 10 days before anyone on Earth even knew this object existed. And by the end of this video, you'll understand exactly why two of the most powerful telescopes ever built, James Webb and the Vera Rubin Observatory, both ended up looking at the same object without ever planning to. On July 1st, 2025, a survey system called ATLAS, short for Asteroid Terrestrial Impact Last Alert System, detected something moving through our solar system from a facility in Rio Hurtado, Chile. At first it received a technical designation, C2025N1, but within days, astronomers confirmed something remarkable. This object wasn't from our solar system at all. It had arrived from somewhere else entirely, out of interstellar space, and it was only the third such object ever confirmed in human history. It was named 3I Atlas, and almost immediately observatories around the world turned their attention toward it. Here's where things get interesting. A few weeks after the official discovery, scientists working with the brand new Vera C. Rubin Observatory in Chile went back through their archived data. Just routine housekeeping, checking old test images from a phase called science validation. And there it was, sitting quietly in the background of images taken on June 21st, 2025, a full 10 days before Atlas ever announced the discovery. That was 3I Atlas. Nobody at Rubin Observatory even knew it was there at the time. The telescope wasn't hunting for interstellar objects that night. It was simply doing calibration work, testing its systems, pointed in a direction that by pure chance happened to include the exact patch of sky where this interstellar visitor was quietly passing through. Rubin kept accidentally photographing the object all the way through July 20th, 2025, gathering nearly 100 exposures in total, and researchers eventually used 49 of those images in a full scientific study. This makes Rubin Observatory's images among the earliest and highest resolution pictures of 3I Atlas that exist anywhere on Earth, captured entirely by accident before most of the world even knew the object was real. What did those images actually reveal? Quite a lot, honestly. Rubin's data showed that the object had a growing coma, meaning a cloud of gas and dust surrounding its core, and that cloud expanded by more than 50% during the observation window as the object moved closer to the sun and began heating up. That alone is completely normal comet behavior. But there was one detail that genuinely surprised scientists. The object had a dust tail pointing toward the sun instead of away from it. Normally a comet's tail points away from the sun because sunlight physically pushes dust particles backward. A sunward-facing tail is rare, though not unheard of. Researchers have observed a similar effect in at least one other distant comet before. Scientists explain this using something called anisotropic dust emission, essentially meaning the dust wasn't being released evenly in all directions from the object's surface, which can create unusual tail shapes depending on the viewing angle. It's a strange, interesting detail, but it's explainable science, not an unsolved mystery. Before moving on to the chemistry side of the story, it's worth understanding exactly what kind of telescope managed to catch this object completely by accident. The Vera C. Rubin Observatory sits atop a mountain called Cerro Pachón in Chile, chosen specifically for its dry air and dark skies, ideal conditions for observing faint objects in deep space. Its main mirror measures 8.4 meters wide, roughly as wide as a tennis court is long, and attached to it is the LSST camera, the largest digital camera ever built, capable of capturing 3,200 megapixels in a single image. At the time it photographed 3I Atlas, this observatory hadn't even officially begun its real mission yet. It was still in a testing period called science validation, essentially a dress rehearsal phase where engineers and scientists check every part of the system, the optics, the camera, the software pipelines, before the real 10-year survey begins. During this phase, the telescope is pointed at various patches of sky simply to test image quality, calibration accuracy, and system reliability, not to hunt for specific objects. That's exactly why nobody realized 3I Atlas was sitting inside these test images for weeks after they were taken. Researchers only discovered it later, after the official announcement, when they went back through the archived commissioning data, specifically to check whether it might have appeared earlier by coincidence. And it had, hiding quietly in the background of ordinary calibration images, a full 10 days before the rest of the world even knew to look for it. Here's the part that shows just how good this discovery process really was. Rubin captures images across 6 different filters, covering different colors and wavelengths of light, often labeled U, G, R, I, Z, and Y. Scientists managed to measure the object's position across all these bands with a typical precision of about 70 milliseconds, an extraordinarily tiny angle given how far away and faint the object actually was at that point. For comparison, Rubin's general precision on fixed, unmoving background stars is even sharper, closer to just 3 milliseconds. So the slightly coarser precision on 3I Atlas simply reflects the difficulty of tracking something actually moving relative to the background sky. This level of detail allowed the research team, led by astronomer Colin Orion Chandler, along with more than 300 other collaborating scientists, to publish a full paper analyzing the astrometry, meaning precise position tracking, along with the brightness, shape, and activity levels of the comet, based entirely on this accidental early data. Now let's talk about James Webb, because this is where the story connects. On August 6, 2025, the James Webb Space Telescope turned its near-infrared spectrograph instrument, called NIRSpec, directly toward 3I Atlas. This was Webb's first real look at the object, following observations already made by the Hubble Space Telescope and NASA's SPHEREx mission. Webb's task here differed from Rubin's. Rubin captured images, essentially photographs, showing shape, brightness, and movement. Webb went further, using spectroscopy to actually break down the light coming from the comet and determine its chemical composition, almost like a fingerprint. And Webb found something unusual almost immediately. Inside the comet's coma, scientists detected carbon dioxide, water ice, carbon monoxide, and a foul-smelling compound called carbonyl sulfide. All fairly typical comet ingredients on their own, but the ratio of carbon dioxide to water was the highest ever recorded in any comet observed by scientists, whether from our solar system or interstellar. That ratio matters because it tells astronomers something about the environment this object originally formed in. Environments with different temperatures and different levels of sunlight produce different chemical ratios inside a forming comet. Then, in December 2025, Webb looked again. As 3I Atlas made its closest pass by the Sun on October 29, 2025, a moment scientists call perihelion, the comet's ancient ice began rapidly turning to gas, producing a brighter, more active coma that was ideal for detailed observation. Webb captured this moment on December 22, 2025, shortly after the object made its closest approach to Earth on December 19th, passing at a safe distance of about 168 million miles, roughly 270 million kilometers, posing zero threat to our planet at any point. In the second, deeper look, Webb measured something even more revealing. Specific ratios of carbon and deuterium, sometimes called heavy hydrogen, locked inside the comet's ice. These exact ratios don't match anything found in comets formed inside our own solar system. Working backward from that chemical signature, researchers were able to estimate where and when this object was actually born, and the answer was staggering. Based on Webb's data, scientists calculated that 3I Atlas likely formed somewhere between 10 and 12 billion years ago, in a cold, distant region of the early Milky Way galaxy. For comparison, our own solar system, including Earth, the Sun, and every planet we know, is only about 4.6 billion years old. This means the ice and dust making up this comet had already been floating through space, frozen and unchanged, for billions of years before our own Sun had even finished forming. Some researchers have pointed out that this makes 3I Atlas nearly as old as the universe itself, estimated to be roughly 13.8 billion years old. This research was formally published in the scientific journal Nature on June 22, 2026, after passing peer review, meaning independent scientists checked the data and conclusions before publication was allowed. So here's the honest answer to the big question everyone online keeps asking. Is this the terrifying alien object some corners of the internet claim it is? No, it isn't. Scientists have been extremely clear and consistent about this, and it's worth walking through exactly why they're so confident, rather than simply taking their word for it. First, the object behaves exactly as a comet is expected to behave, developing a coma as it approaches the Sun and releasing gas and dust in a pattern matching physical models built from decades of studying comets within our own solar system. Second, the chemical composition detected by Webb, carbon dioxide, water ice, carbon monoxide, and carbonyl sulfide, are all completely ordinary comet ingredients. The same basic building blocks scientists have already cataloged and studied for decades in comets formed right here in our solar system, just present in a different ratio, which tells us about temperature and formation conditions rather than suggesting anything artificial or engineered. Third, the object's trajectory follows the predictable laws of gravity and orbital mechanics, with no unexplained deviations, no sudden shifts in speed or direction that couldn't be explained by natural outgassing. The same kind of small course corrections comets have displayed for as long as we've been tracking them. Every single measurement, from Rubin's early images to Webb's detailed chemical analysis, points to one conclusion. This is a completely natural interstellar comet made of ordinary ice, gas, and dust, just like the comets we already study inside our solar system, only far, far older and originating from somewhere outside it. Astronomers have stated directly that the evidence proves 3I Atlas is not an alien probe, and that framing it that way actually undersells how genuinely amazing the real science is. Because consider what this object actually represents. It's a physical sample, a real fragment of frozen material from another region of our galaxy entirely, from a very distant era, before our own sun even existed, and before Earth had formed, that just happened to drift close enough for our telescopes to study in detail. Scientists have compared this opportunity to finding a message in a bottle that has been floating across an ocean for billions of years. Except here, the ocean is the entire galaxy, and the bottle is made of ancient ice instead of glass. That's not science fiction. That's one of the rarest natural events astronomers could ever hope to witness in their careers. And it happened to occur at the exact moment humanity has some of the most advanced telescopes in history pointed at the sky. It's also worth understanding why this particular chemical signature was so useful for determining the object's age in the first place. Deuterium, sometimes called heavy hydrogen, is a slightly heavier version of a normal hydrogen atom. And the ratio of regular hydrogen to deuterium found inside ice can act almost like a chemical clock. This ratio changes very slowly and predictably based on the temperature and radiation conditions present when that ice first formed billions of years ago in whatever cold, distant cloud of gas and dust eventually became this comet. By carefully measuring that ratio using Webb's near-infrared spectrograph, researchers could work backward and estimate not just how old the ice is, but roughly what kind of environment it originally formed in, something scientists call galactic chemical evolution. Because our galaxy has been slowly changing its chemical makeup over billions of years, as generations of stars have lived, died, and seeded space with heavier elements, an object formed extremely early in the galaxy's history carries a slightly different chemical fingerprint than something formed more recently. That's exactly the kind of subtle signature Webb was built to detect, and exactly why an interstellar object like 3I Atlas is such a valuable target. It's essentially a frozen time capsule from an era of our galaxy no telescope has ever been able to sample directly before now. Let's put some real numbers on the table because the scale of this object is genuinely impressive on its own. 3I Atlas is only the third interstellar object ever confirmed passing through our solar system, and comparing it to the first two really shows why scientists are so excited about this particular visitor. The first was Oumuamua, discovered in October 2017 by a survey telescope in Hawaii. Oumuamua was unusual because of its strange elongated shape, and because it showed a small unexplained acceleration as it left the solar system, something that briefly fueled a lot of online speculation, though most astronomers concluded this was most likely caused by gas venting off its surface, a completely natural process, simply one that was harder to directly observe, given how faint and distant the object already was by the time telescopes caught up to it. The second interstellar object was Borisov, discovered in 2019 by an amateur astronomer in Crimea. Borisov behaved much more like a familiar, ordinary comet, complete with a visible tail and coma, making it easier for scientists to study and compare directly with comets that formed inside our own solar system. 3I Atlas is the third, and in some ways the most extreme of the three. Its orbit is far more hyperbolic, meaning far more sharply curved and open-ended than either of the previous two objects. Scientists measure orbital shape using a number called eccentricity, where a value of exactly 1 marks the boundary between an orbit that eventually loops back and one that never returns. 3I Atlas has an eccentricity of about 6.14, an extremely high figure confirming that this object was moving so fast on such a wide-open trajectory that it was never gravitationally bound to our sun at any point in its journey. It was traveling at roughly 137,000 miles per hour, or about 221,000 kilometers per hour, as it approached the inner solar system. An almost incomprehensible speed that leaves no doubt this object simply originated somewhere else entirely, passed through briefly, and is now leaving again permanently on a one-way trip that started somewhere else in the galaxy and will end somewhere else entirely, long after it leaves our cosmic neighborhood behind for good. Based on its speed and trajectory, researchers calculated something called a kinematic age, essentially estimating roughly how long the object has likely been drifting through interstellar space. Their estimate landed somewhere between 3 and 11 billion years, a range that lines up closely with the separate chemical age estimate that came later from Webb's data. Researchers have also noted that, statistically speaking, it's extremely unlikely this object has passed as closely by another star as it just passed our own sun, meaning our solar system may be the closest stellar encounter this ancient traveler has had in billions of years of drifting alone through the emptiness of the galaxy. Hubble space. Telescope observations helped scientists estimate the size of the object's solid core, or nucleus, placing it somewhere between about 440 meters and 5.6 kilometers wide. A fairly wide range, because measuring the exact size of a small, distant, actively outgassing object is genuinely difficult, even for our best instruments, since the bright surrounding coma of gas and dust tends to obscure the true edges of the solid nucleus underneath. On top of Hubble, Rubin and Webb, other missions joined the effort, too, turning this into one of the most heavily observed objects in recent astronomical history. NASA's SPHEREx mission observed infrared light coming from the object's coma, detecting dust, water, organic molecules, and carbon dioxide, adding another layer of confirmation to what Webb had already found, using a completely separate instrument in a slightly different wavelength range. NASA's TESS mission, usually used for hunting planets around other stars by watching for tiny dips in starlight, was also redirected for a special observation run, specifically to study the comet's activity and rotation. An unusual but valuable use of a telescope not originally designed for comet science. Even a European spacecraft called JWST, currently on its way to study Jupiter's moons, managed to capture an image of 3I Atlas in November 2025, simply because it happened to be in a useful position along its own separate journey through the solar system. In total, this makes 3I Atlas one of the most thoroughly observed interstellar objects in history, studied by an entire international lineup of telescopes and spacecraft, all pointing at the same tiny, ancient traveler at different points during its brief visit through our solar system, each contributing a different piece of the overall picture. So why does it matter that Rubin and Webb both ended up looking at the same object? Because together they represent two completely different but equally powerful ways of studying the universe. Rubin Observatory is built for speed and coverage, constantly scanning huge sections of the sky, which is exactly why it accidentally caught 3I Atlas in the first place, purely because it happened to be testing its systems in the right place at the right time. Webb, on the other hand, is built for depth, for extremely detailed, precise observations of one target at a time, which is exactly how it managed to break down the comet's chemistry down to individual molecules and isotope ratios. One telescope found the object first, completely by accident. The other figured out what it actually was, where it came from, and roughly how old it is. Neither discovery would mean nearly as much without the other. Rubin gave scientists the earliest possible timeline and detailed shape data. Webb gave scientists the deep chemical proof needed to trace this object's origin back billions of years into the history of our galaxy. The story also says something bigger about where astronomy is heading right now in 2026. The Vera Rubin Observatory officially began its 10-year survey of the sky on June 30th, 2026, called the Legacy Survey of Space and Time. Its entire purpose is to scan the sky repeatedly every few nights for an entire decade, catching exactly these kinds of unexpected objects: asteroids, comets, and rare interstellar visitors, often before anyone else even knows to look for them. The fact that Rubin managed to accidentally photograph an interstellar comet before it was even officially discovered, while still in its testing phase, months before its real survey even began, is a genuine preview of what this observatory will be capable of once it's fully up and running night after night for the next decade. Scientists expect more interstellar objects to be found in the coming years as this survey continues. And when they are, there's a very real chance Rubin Observatory will be one of the first instruments on Earth to spot them, simply because, unlike almost every telescope before it, it genuinely never stops watching the sky. Meanwhile, James Webb continues doing exactly what it was built to do, taking whatever object gets discovered, wherever it comes from, and breaking its light down into detailed chemical evidence that reveals where it was born and how old it is. This is possible because Webb operates far out in space itself, orbiting roughly 1.5 million kilometers from Earth, away from the heat and light interference of our own planet, allowing its infrared instruments to detect incredibly faint signals that would otherwise be completely lost to telescopes sitting on the ground. Together, these two observatories, one constantly scanning wide areas of sky from a mountaintop in Chile, and one capable of incredibly precise, deep analysis from deep space, form a kind of early warning and deep investigation system for anything unusual that passes through our cosmic neighborhood. 3I Atlas just happened to be the first major example of these two systems working together, even though nobody actually planned it that way, and it almost certainly won't be the last. Right now, 3I Atlas has already passed its closest point to the Sun and Earth, and is now moving back out of our solar system, heading off into deep interstellar space again, quietly and permanently. Scientists continued gathering more data as long as the object remained observable, right up until it became extremely faint and much too far away to track effectively, coordinating observations across ground-based telescopes, space telescopes, and even a spacecraft on its way to Jupiter, all working together to squeeze every last bit of usable data out of this brief, one-time visit. What we're left with is a genuinely remarkable scientific record. A comet born 10 to 12 billion years ago, drifting quietly through the galaxy for almost the entire history of the universe, before briefly and completely by chance, crossing paths with a handful of human-made telescopes on a small, quiet blue planet, long enough for us to photograph it, analyze its chemistry, and calculate roughly how old it actually is, before it disappears again for good, likely never to be seen by human eyes or instruments again. That's the real story here. Not an alien object, not a terrifying threat, but something arguably far more impressive. Direct physical evidence from a completely different corner of our galaxy, formed before our own solar system even existed, confirmed independently by multiple world-class telescopes working completely independently of each other, and in Rubin's case, working completely by accident, simply because it happened to be pointed in the right direction on an ordinary test night. It's a genuine reminder that some of the biggest discoveries in science don't come from searching harder. They come from having good enough instruments running often enough that when something rare finally drifts past, you're already there to catch it. If you want to keep seeing real, fact-checked breakdowns like this one every time something genuinely new happens in space, subscribe now and turn on notifications. Because stories like this one are only going to become more common as Rubin Observatory settles into its full 10-year survey. Drop a comment and tell me which fact surprised you the most. The accidental discovery 10 days early, the sunward-pointing tail, the fact that this object is older than our entire solar system, or the sheer number of telescopes and spacecraft that ended up studying it before it finally left our solar system for good. Thanks so much for watching all the way through to the very end. I'll genuinely see you in the next one.